I'm going to do a quick proof for the product rule for logarithms. I'm going to start out with showing you, reminding you that the product rule for exponents tells us that if we have two powers of the same base, we multiply those together. What we're going to do is we're going to add those exponents. Logarithms are exponents. We have a mantra. So we're going to see how that works. Here we have a product of these two powers. But here, for logarithms, we're talking about the product that's inside the argument, the input of the logarithmic function. And we're claiming that the log of the product is equal to the log of the first factor plus the log of the second factor. It must be the same base, same thing as up here, same base, same base. So we start by letting the log of x base b equal m, and the log of y base b, let that be n. And see, they even have the same names as those exponents. Then we'll write them in exponential form, so we'll say b to the m is what x is, and b to the n is what y is. Then we will look at the product xy, because that's what the argument of this log is. This is going to equal b to the m times b to the n, which is going to be b to the m plus n. So now we're going to rewrite it back into logarithmic form like we started. So we're looking at the log. Here's my base. This is my exponent, so that's going to go on the other side of the equal sign. This is my argument. Right, I've just rewritten that. But m and n, we substituted up here, so we're going to back substitute. M is log of x base b, n is log of y base b. So without this little piece in the middle, what we are left with is what we started with, what we claimed. QED. There you have it.